So, very good evening, everyone. Today we are going to start the refraction of light through a prism. Okay. So, refraction is nothing but the change of the original path of the light when it passes from one transparent medium to other is called as refraction. So, I'm just going to write definition over here so that you all have to write and remember also. So, what is refraction of light? So, when light ray passes from one transparent medium to other transparent medium, it changes its original path. That phenomenon is called as refraction of light.
Sir, am I audible?
Yes, refraction of light. Okay, so have you understood what is refraction of light, everyone?
Yes, sir.
Okay, so this is the definition for that. Okay, so let's discuss what is given in your notebook. Okay, so in your notes, so what is prism, that we have to understand first. So prism is a triangular, it is the two triangular base and three rectangular lateral surface. Okay, all they together form the prism. Okay, so like we have structure of prism, like here we had one triangle from front side, one triangle from back side, and these three, one is at the base, one is one side and one is another side. Okay, so three we have rectangular shape and two we have triangular shape. This is the triangular, this is triangular. Front, in this side we have rectangular, in right side we have rectangular, and left side we have rectangular. Okay, so all these three and two, five faces mixed together the prism, and it is made up of the transparent material like glass or maybe the plastic. Okay, so surface, okay, included in, and they are inclined on each other. The angle between the two lateral faces is called as angle of the prism, and generally it is of 60 degree. Sometimes it changes also, but generally it is of 60 degree.
Then it's an equilateral.
Yeah, equilateral, we can say triangular prism. Okay, but sometimes it may be changed. Okay, so this is nothing but the angle of the prism, that one. Okay, so now we are going to move further. The angle of deviation means what? First we are going to understand the terminology, and then we will understand the dispersion of light. Okay, so we are just understanding the terminology. So I am going to scroll it down. So before that you have to take a screenshot for that part. Take a screenshot, everyone. This is the first screenshot for today. Done?
Yes, sir.
Okay. Now we are going to understand the angle of deviation. Okay. So this is angle of deviation. And in diagram, here we have the angle of deviation. Okay. This one. Okay. This is the incident light. Okay. And it changes its path, but that the dotted light, which is the actual path of the light. Okay, and that angle, the angle which is formed between incident ray and emerging ray is called as angle of deviation. Very important, you have to remember, huh? What is angle of deviation? This is the emerging light.
between
Yes, this is the emerging light, and this is emerging light ray, and this is the incident light ray. Okay, so the angle which is formed between incident ray
and emergence.
emerging ray, yes, it is called as angle of deviation. Understood, everyone?
Yes, sir.
Yes, sir.
Yes. So the angle between the incident ray and emergent ray is called as angle of deviation. And it depends on like a material to material. Okay. So dispersion of white light by through the glass prism. Now we are going to understand. Okay.
Sir, take
So,
Akil in.
हाँ बेटा.
Sir, Akil in.
हाँ.
Sir, Akil को अंदर ले sir. Sir, he's in waiting room. He's in waiting room.
I'm not getting what you are saying. Okay. So now we are going to understand the dispersion of light. It is very important, no? Okay. So we know white light contain all the visible range of light. Okay. What is the visible range of light? So it is about between 400 nanometer to 800 nm. Okay. This is the wavelength of light. So in between, okay, we have all the 7 color here. That's why, and they are visible to us. That's why they are called as visible range of.
Sir, which type of rays are not visible to us on each extreme on the nanometer line?
Like we have X-ray, infrared, ultrasonic waves. Okay, they are invisible.
Yes, sir. Which ones are on the lower end and which ones are the higher end?
Okay, okay. For that, I will show you the chart. Ultrasonic and we have infrasonic. So ultra means they have visible like wavelength less than the visible range of light. Okay, I'll give you the chart after the class. Okay, don't worry. Between the class, I will
Yes, sir.
see that. Okay. See, so when white light enters the prism, so here we know white light contain all the 7 color. Okay, which are they? V, I, B,
Here.
Y, O, and R. Yes, Vibgyor. So here we have the violet. I is indigo. I is indigo. B is blue. G means green. Y means yellow. O means orange. And R means red. Okay. So these are the 7 color which are the content of, we can say the component of the white light. They are the component of white light. Okay. Yes. So see, all these 7 color have different wavelengths. Okay, different velocities when they like transfers from one medium to another medium. So due to difference in their refractive index, okay, their angle of deviation is also different. See, I'm writing very important point here. Due to difference in wavelength and refractive index. Okay, due to difference in wavelength and refractive index, they have different angle of deviation. Okay, so due to difference in angle of deviation, they deviate from the different angle. Okay, everyone, you're getting the point.
Yes, sir.
Yes, sir.
Yes, that's why all the 7 component color of the white light, they have different angle of deviation, so they appears different, in the form of spectrum. Okay, they appears in the form of, different color in the form of spectrum. Okay, so this phenomenon is nothing but the dispersion of light. So now we are going to define what is the dispersion of light now. Okay, so what is dispersion of light? So when white light passes through the prism, all the component color of the white light gets separated according to their angle of deviation. This phenomenon, and again we can add, and all the 7 color appears in the form of spectrum, is called as dispersion of light. It's called as dispersion of light. So what causes the dispersion? Their
Due
angle
to
of,
differentiation in refractive indexes.
yes, but we would say difference in angle of deviation. Yes, and angle of deviation is different due to the refractive index and their wavelength. Okay, so the red color which appears at the top, which have the highest wavelength, and the light which have highest wavelength have less angle of deviation, and angle of deviation will be the less. Okay, and the light, like we have violet here, which have the highest angle of deviation. If we will measure from here to here, the violet color have highest angle of deviation, but have the lowest wavelength among all the 7 color. Okay, everyone.
Yes, sir.
So
Yes,
many
sir.
question, many MCQs arises from here. Okay, we will discuss that one by one. So take a second screenshot for today.
So done.
Everyone done? Any doubt here, beta? What causes and why dispersion takes place? What is refraction? Any question here?
No, sir, no question.
Everyone?
Sir, can you repeat the causes again?
Causes. Okay. See, cause I have already given over here. Due to difference in wavelength and a refractive index, all the 7 color have different angle of deviation. That's why all the 7 color are, we are getting in the form of separate 7 color spectrum. Okay, because they have different angle of deviation. Okay.
Okay, sir.
And yes, and the red color have the highest wavelength and have the lowest angle of deviation among all the 7 color. And violet color have lowest wavelength and highest angle of deviation among all the 7 color. Okay, you can observe from the diagram only. If you will measure, wait a second, let me change the color of ink. Yes, see, if you will measure from here to here, so this angle of deviation for red color, and if you will measure angle from here to here, so that will be angle for the violet color. Is it? So angle of deviation for violet color is higher as compared to the red color. And for the wavelength, okay, so wavelength of red color is higher and violet color is lower. Okay.
Okay, sir.
Yes. Okay. Okay. So inclined refracting surface of the glass prism shows the exciting phenomenon called dispersion of light. Okay. So now here we are going to understand splitting of white light into the band of color, means the cause. So the band of colored component of the light, okay, beam is called as spectrum. So the band of all the 7 color means Vibgyor, together we would say it is nothing but the spectrum. What is spectrum? It is the component color of the white light, okay, in the form of waveguide means the 7 different color is called as beta spectrum. And the splitting of the light into the component color is called as dispersion. What is dispersion? It is nothing but the splitting of white light into its component color is called as dispersion. Okay. The different component color of the light bends at a different angle. Okay, means nothing but the angle of deviation. It is nothing but the cause. Okay, with respect to incident angle and angle, the red light bends least, means red light have the lowest angle of deviation, while the violet bends most, means violet color have highest angle of deviation. Okay, that point is clear from here. Okay, any doubt here?
Sir, once repeat, sir.
Okay, so suppose I am drawing prism here. Okay, suppose this is the incident ray and this is the actual path of the incident ray, but due to the change in medium, it get refracted from here. So we are getting here the two color. Okay, so this is the red and this is the violet. So angle of here to here is the angle of deviation for red color, and from the measure of angle from here to here is called as angle of deviation for violet color. So angle of deviation for violet color is higher as compared to angle of deviation for red color. Okay, Ahil.
Yes, sir.
Okay. Now, Isaac Newton was the first who has obtained the spectrum of sunlight by using the glass prism. So, who has obtained first by the spectrum of the light? So, Sir Isaac Newton. Okay.
Yes, sir.
He tried to split the spectrum while light, white light more by using another similar prism, but he could not get any more colors. Okay, but like he has obtained all the 7 color, so he has made different prism by using different angle of the prism, and he has performed the same experiment in order to like observe more color, but he didn't find. That means all the 7 color he got all the time. That's why that phenomenon is nothing but called as the spectrum of for the 7 color only. Okay, because we are getting only 7 color during the dispersion of white light. Okay. Okay.
Yes,
He
sir.
repeated.
Sir, it was clear that 7 color was seeing properly.
Yes. Even in rainbow, there is a natural phenomenon where you can find all the 7 color.
Sir, today I have seen rainbow, but only light color was seeing, sir. I don't see dark color.
Okay, okay.
So light rainbow, sir.
Okay, so it is due to that rainbow is quite far away from you, and having the faint color. Faint means not dark color, due to which you won't find all the 7 color there.
Yes,
But
sir.
all the 7 color was there, but most of the color
Sir?
get refracted towards when coming towards you.
Sir, it will be absorbed, right?
No, they get refracted because
Okay.
yes, between the rainbow and you there is a quite distance, and between distance we have the difference density or different refractive index, so due to which most of the light get refracted before coming to you.
Yes,
Sir?
sir.
Sir, can you explain internal refraction once?
We will discuss here, we will going to understand that point, don't worry. We have the rainbow
Sir?
also, don't worry. In rainbow we will discuss that.
Okay, sir.
Yeah.
Sir, I have a doubt. Sir, we know that light always travels in a straight line.
Yes.
So when we see a rainbow, even that is refraction. So why is it like a curve?
Okay, so we will discuss that in rainbow part.
Oh, okay.
Yes. Okay, so he repeated the experiment using the second prism Okay, he has repeated the same, like he has got the spectrum over here and he has put another prism, but it is inverted. It is inverted. Okay, and after passing all the 7 color through the prism, he got the same light, means the white light only. Okay, if we will combine both the prism base to base like this, okay, this is the prism 1 and prism 2, so that resulting prism is called as Nicole prism. Nicole prism. Nicole's prism. Okay, what is Nicole prism? When two normal prism join base to base, and you know these two prisms are joined with the help of the adhesive called Canada balsam. Canada balsam. Okay, because Canada balsam is the adhesive which do not like create any air bubble while pasting these two prisms with each other, and does not does not change their transparency also. That's why Canada balsam is used for the pasting these two prism base to base. Okay, such prism is called as Nicole's prism. Okay.
Yes,
Yes.
sir.
Okay, so he like performed the dispersion of light over here, and again he put another prism inverted light in right in front of the spectrum, means he has performing anti-dispersion, means against the dispersion. Okay, so he repeated the experiment using second prism on the inverted position with the respect to the first prism, and he found the white light, and he concluded that the white light contained all the 7 colors only. Okay, and allowed the color of the spectrum passes through the second prism, and he found the white light emerging on the other side of the glass prism. Okay, and then he conclude that, what he conclude? He has concluded that sun is made up of the 7 visible color, or not sun but sunlight, we would say sunlight. Okay, sunlight is made up of the 7
Sir,
visible
what if
colors.
we keep both the prisms in the same manner, means both are upright? Then what will happen?
Oh, so we will get 7 color only, no? Again,
Same thing will happen.
yes, yes. Same thing means what? See, all the 7 color, if you will find spectrum over here, then you will find the same spectrum over here, just little down. Okay.
Okay, sir, understood.
Okay, so just take a screenshot. Wait a second. You have to take screenshot from here. Okay, done. Okay, another from here for the diagram.
Done, sir.
Okay.
Done, sir.
Okay.
And
Okay, so till here, any doubt, because we have completed the dispersion of light. So
Not-
doubt first.